Ever wondered why a rolling ball stops after a while, or why a swinging pendulum eventually comes to a standstill? Well, it all comes down to a fundamental concept in physics known as energy. Energy, in the most basic sense, is what allows things to do work, to change, to move. Now let's think about a moving object. Could be a car zooming down the highway, a bird soaring in the sky, or even the planets revolving around the sun. What do they all have in common? They're all in motion, and this motion means they possess a particular kind of energy, which we call kinetic energy. Kinetic energy is essentially the energy of motion. Whether it's the tiniest atom zipping around or the largest galaxy spinning in space, anything that's moving has kinetic energy. So if it moves, it's got kinetic energy. Simple as that. Now that we know what kinetic energy is, how do we measure it? We use a formula, and not just any formula, but one that might look a bit complex at first glance. But don't worry, we're going to break it down, so it'll be as easy as pie to understand. The formula for kinetic energy is 1/2 times mass times velocity squared, or in simpler terms, 1/2 the mass times the speed squared. It's often written as K equals 1/2 mv squared, where Ke is kinetic energy, m is mass, and v is velocity. Now, let's dive a bit deeper into this formula. First, we have mass. It's a measure of how much matter is in an object. It's like when you pick up a bowling ball versus a tennis ball. The bowling ball has more mass, and you can feel it. Then we have velocity, which is a fancy word for speed in a specific direction. It's like when you're riding a bike. The faster you pedal, the more speed you gain, and the more kinetic energy you have. But here's the thing. Velocity in our formula isn't just v, it's v squared. That means the velocity is multiplied by itself. So if you double your speed, your kinetic energy doesn't just double, it quadruples. This is why cars consume so much more fuel at higher speeds. The energy needed increases exponentially with speed. Finally, we multiply our mass and velocity squared by 1/2. This is because the kinetic energy an object has isn't just due to its speed or its mass alone, but a combination of both. And the 1/2 is there due to some mathematical reasons, which we won't get into right now. So, to summarize, kinetic energy depends on both mass and velocity. More mass means more kinetic energy. More speed also means more kinetic energy. But speed plays a bigger role because of that squared term. So remember, more mass or more speed means more kinetic energy. Kinetic energy isn't just a theory, it's at work all around us, every day. Let's dive into the concept of kinetic energy with some real-life examples. You see, kinetic energy is the energy of motion. It's the energy that's producing the action around you. It's in the spinning gears of your bike, the rolling wheels of a skateboard, and the falling rain from the sky. Consider a moving car. As the car accelerates, it gains speed, and thus its kinetic energy increases. When you're sitting in a car that's zooming down the highway, you're actually sitting in a bundle of kinetic energy. And when the car comes to a stop, the kinetic energy is converted into other forms of energy, like heat in the brakes. Now, let's think about a thrown ball. When you toss a ball, you're giving it kinetic energy. The faster you throw it, the more kinetic energy it has. And that kinetic energy keeps the ball moving until something stops it, like when it hits the ground or a wall. Even when you're just playing catch in the park, you're witnessing kinetic energy in action. What about a falling leaf? You might wonder, how can something so light have kinetic energy? Well, remember, kinetic energy is about motion. As the leaf falls from the tree, it's moving, right? That's kinetic energy. Even though the leaf is light, it still has kinetic energy because it's in motion. It's just that the amount of kinetic energy is small compared to, say, a falling rock. And let's not forget about running water. Whether it's a rushing river or a trickling stream, flowing water is full of kinetic energy. The water is moving, so it has kinetic energy. The faster the water moves, the more kinetic energy it carries. This kinetic energy can be harnessed to do work like turning a water wheel or generating electricity in a hydroelectric power plant. And that's just the tip of the iceberg. Kinetic energy is everywhere. It's in the beating of your heart, the waving of a flag, and even the wagging of a dog's tail. So, the next time you see a moving car, a thrown ball, a falling leaf or running water, remember you're witnessing kinetic energy in action. You're seeing the energy of motion, the energy that powers our world. From cars to falling leaves, kinetic energy powers our world. Energy doesn't just disappear, it transforms. When we talk about the transformation of energy, we're really talking about energy changing from one form to another. And kinetic energy, the energy of movement, is no exception. It's a real shapeshifter in the world of energy. Imagine a bouncing ball. It starts with potential energy when it's held in your hand. Then it transforms into kinetic energy as it falls, moving faster and faster. But when it hits the ground, some of that kinetic energy doesn't just vanish. Instead, it changes into other forms of energy. First, there's sound energy. That's the thud or bounce you hear when the ball hits the ground. This is kinetic energy transforming into sound waves that travel through the air to your ears. Next, there's heat. If you've ever rubbed your hands together quickly, you've felt how movement can generate warmth. That's kinetic energy transforming into thermal energy. The same thing happens when the ball hits the ground. The impact creates friction, and that friction generates a tiny bit of heat. Lastly, there's the transformation back into potential energy. After the ball hits the ground and bounces back up, it's gaining height and with it, potential energy. This is the energy the ball has stored up for its next fall, ready to transform back into kinetic energy again. Now let's consider a light bulb. When we switch it on, electrical energy is transformed into two different forms. First, there's light energy, which is what allows us to see in the dark. But there's also thermal energy. Yes, that's why light bulbs get hot. So you see, even here kinetic energy in the form of moving electrons is transformed into something else. In both these examples, energy is conserved. It doesn't get lost, it just changes form. This is known as the law of conservation of energy. So, kinetic energy can change into other forms of energy, but it never just goes away. Now that we've learned about kinetic energy, let's think about how it affects our lives. Kinetic energy, as we've discussed, is essentially the energy of motion. Anything that moves, from a rolling ball to a flying bird, possesses this energy. It's a fundamental concept in physics, but it's also something we experience in our day-to-day lives. Think about when you throw a frisbee. As you release it from your hand, you're giving it kinetic energy. The frisbee uses this energy to travel through the air until it eventually slows down and falls to the ground. The energy hasn't disappeared though, it's just been transferred. In this case, the kinetic energy has been converted into potential energy, which is stored energy. Understanding kinetic energy can also help us comprehend how certain technologies work. For example, wind turbines transform the kinetic energy of the wind into electrical energy. The wind moves the turbine's blades, creating kinetic energy. This energy is then converted into electrical energy that can be used to power homes and businesses. Even in the human body, kinetic energy plays a vital role. When we walk, run, or lift weights, our muscles are applying force to create movement. This movement, or kinetic energy, is what allows us to navigate the world around us. The beauty of kinetic energy is that it's always in play, always in motion, constantly being transferred from one form to another. It's the energy that powers the universe, from the smallest atom to the largest galaxy. So the next time you kick a soccer ball, ride a bike, or simply wave your hand, remember that you're experiencing the power of kinetic energy. It's this energy that propels the ball forward, keeps your bike moving, and allows your hand to wave. The world is a symphony of movement, and kinetic energy is the maestro, directing every motion, every action, and every reaction. It's everywhere, in everything, driving the constant dance of energy transformation. If you want to know more about other forms of energy, go to my channel, The True Facts.